who are the sperm carriers. And insects landing on the flowers, of course, pick up the pollen, and that's the sexual act from the point of view of the flower. This is a primrose, and as you can see, this bush is in full sexual display. Full of flowers, each flower a landing pad for the pollinator, and if you look around, you can see
it. Beautiful.
Indeed, there's a little bee. And what do these do? They fill up on nectar, they get dusted with pollen, they look for another flower. The pollen gets incidentally dropped on that other flower, pollination is affected. Now, if you look at this flower, you say, aha, this is a landing pad advertised in yellow.
But for the flower's advertising to work, bees have to be able to distinguish between different colors. An ingenious experiment reveals whether or not they can. Glass bowls are located on squares of different colors. Food is placed only in the bowl on the blue square. Kirk Vischer is with the University of Southern California.
I've trained these bees from their hive about 100 meters away from here, and they're coming back and forth, foraging for the sugar syrup that I provide. And as they've done that, they've learned that the way you find the food is to come to the blue card. And then if we move that to a different part of the array, they will search for the food, and as you can see here, they're searching for the blue among the various colors.
Odorless, the food can't be detected by smell.
When we provide them with grays instead and one colored card, they unerringly find the colored card among the different shades of gray, which indicates that they're actually using the different wavelengths of light rather than just the different degrees of reflectance of the grays.
So bees and other insects can distinguish different colors, and color plays a vital role in pollination. The lantana plant is the subject of a study by Martha Weiss of the University of Arizona.
A lot of plants, besides just having flashy or showy flowers, have a little bit more subtlety in the whole system. In lantana, the butterflies quickly learn to visit the yellow flowers that contain nectar and have a receptive stigma and offer pollen, and avoid the orange and red flowers because they don't contain reward for the butterflies.
Yellow flowers open in the morning. During the course of the day, they turn light orange. Overnight, they become a darker orange, and after 2 days, they're red. By next morning, there are fresh yellow flowers with both pollen and nectar, and it's these the butterflies head for.
And this system actually benefits both the plant and the pollinator. It benefits the pollinator because it doesn't waste any time visiting a lot of flowers that might not have a nectar reward, and it benefits the plant because it receives efficient pollination service. This phenomenon turns out to be very common. It happens in flowering plants in at least 75 different families, so it's really very diverse.
Many plants drop flowers that are no longer sexually viable, but species with small blooms, like lantana, commonly retain them to make a more effective display.
When we return, a deadly animal that sees in the dark.
Up here, there are two things that can take your breath away. The scenery and a cold, like the one I've got right now. That's why I depend on something my doctor recommended. Dimetapp Extentabs. For my nasal congestion and runny nose, I take one in the morning, then I breathe easier all day. So when you can't be bothered by a cold, remember to take Dimetapp Extentabs and give yourself some breathing space.
The cost of living, the cost of raising kids,
cost of peanut butter. Oh, something that doesn't go up in price.
It's $19.95? That's good. Okay. Nick, you paying attention?
Yep.
Yeah. Yeah.
Please be serious about Lipton soup.
please be serious about Lipton chicken noodle. Because you can't possibly imagine how long it took to perfect that delicious, tempting golden taste. Even if you stop to think about it, which you probably won't. Lipton chicken noodle. People enjoy it too much.
While every car maker offers protection to help people survive accidents, one company asked, what could be safer than not having an accident at all? Recently, they developed a new anti-lock brake, specially designed to cost less. So this year, anti-lock brakes aren't just for expensive cars, because this year, they're standard equivalent on 95% of the cars they make. The company is General Motors.
The New Year's Eve, we did the town.
Anne Murray, Croonin', Sunday night on CBC.
Go post down. We will have these moments to remember.
Canada's #1 singing star sings your favorite 50s hits in her brand new television special, Anne Murray Croonin'. Sunday night at 9 on CBC, 10 Atlantic, 10:30 Newfoundland.
Some say the making of fine wine is just a craft, but to me, it is more. It is in the knowing of grapes, like the French cross that thrive in my Niagara vineyards. It is in the passing down of skills from master to apprentice, and it is in the moment when nature and the winemaker's skill unite.
Internationally awarded Peller Estates French Cross, the proudest expression of the winemaker's art.
These days, we hear a lot about damage to the ozone layer and the risks this poses for us. It reminds us that life on this planet was possible only because the atmosphere surrounding it screened out most of the sun's damaging radiation. Both life and vision have evolved within this fragile balance. Too much solar energy, and we would be destroyed. Too little light, and we could not see. Persis Drell is a physicist with Cornell University.
Our source of light and color is the sun. We see an object because light from the sun hits the object and bounces into our eyes. The sun is a source of electromagnetic radiation. We like to characterize the electromagnetic spectrum in terms of wavelength. Radio waves have wavelengths of many kilometers. X-rays have wavelengths of billionths of a meter, and the visible light that we see has wavelengths of about 1/2 of a millionth of a meter and produces the colors for us from red to violet. We only see about 5% of the electromagnetic radiation that the sun produces. The reason for that is that between us and the sun, there is this blanket of water vapor called our atmosphere, and the atmosphere very effectively absorbs most of the ultraviolet and most of the infrared radiation, and the radiation in the visible region is able to come through the atmosphere unimpeded down to the Earth, and that's what we see. Now, some species are sensitive to a little farther into the ultraviolet than we are, or a little farther into the infrared relative to us, but basically all living things on the Earth are sensitive to this window of visible light that comes through our atmosphere.
Insects can see parts of the spectrum that we can't, and flowers have evolved to take advantage of it. Entomologist Tom Eisner.
There's more to this flower than meets the eye. Insects can see a color to which we're totally blind. You want to take a look?
Yes.
All right. Let's take this indoors.
So what's the setup here, Tom?
Setup here is a television camera, and we are going to look at this flower with that video system. And on the monitor, television camera is now rigged up as a human eye. Now let me do one little thing and convert this camera into an insect eye so that it can see the ultraviolet. Now you watch the monitor on the count of 3. 1, 2, 3.
That's astounding. It's totally different.
The periphery of all those petals, where you see the pink, is where the ultraviolet is reflected. And out in nature, as the pollinators are approaching these bushes, what they see basically is a bullseye.
So if we were to travel through the bush here with the camera of an insect's eye, would we see a totally different spectrum of flowers?
I think you'd see a new world. I mean, you'd have to imagine being an insect, being a pollinator, flying about and looking for flowers.
But to achieve fertilization, pollen must be carried between flowers of the same species.
If you take yellow flowers, many seem to be similar to us, all potentially confusable. The question is, are they confusable to the insect, or are they different in ultraviolet? An insect landing on the one on the right and looking for one like it would never confuse it with the one on the left.
This image of a house was photographed using a camera sensitive to infrared radiation. It shows escaping heat. And here, the heat given off by a car's brakes. Infrared is heat, and unassisted, we can't see it. But some species can, including the sidewinder rattlesnake. Carl Gantz.
A number of snakes have used an end of the visual spectrum that is not ordinarily utilized, namely the infrared region. One group are the so-called pit vipers, pit because the temperature-sensitive organ, and these hunt at night where they have to triangulate from the two sides onto the prey. Now, the very interesting thing is that the image of the infrared signal is superimposed over the visual image. So the animal can use both the eyes and the infrared together or separately and keep them in register.
For this demonstration, the snake is painlessly fitted with goggles. It will have to detect and strike the target balloon solely by sensing the infrared radiation from the warm water inside.
If you can detect a warm mouse against the wall of a cool tunnel, then you can go hunting mice in the pitch darkness and strike, hitting your prey exactly each time.
No human eye on its own can detect infrared light, and some human eyes are more limited than that. We know that those of us with normal vision have receptors in our eyes, also called cones, that are sensitive to wavelengths of red, blue, or green. And people who are colorblind, most commonly the receptors for red or green are deficient to varying degrees. As a result, their perception of color differs from that of the general population. In this test, the subject, Terry, is given colored caps randomly mixed. Starting with one cap fixed to the board, he arranges the others in what for him appears to be an orderly color sequence. Most color blindness results from reduced levels of photopigment in the cones of the eye. Typically, those cones sensitive to red and green. Elizabeth Sanoki of Washington State University.
Your blues are okay, but when you get some of the other greens and pinks in there. So this would indicate that you have some type of red-green color vision deficiency. Inherited red-green color vision deficiencies are actually more common in men. And this is because the genes that code for the red and the green photopigments are carried on the X chromosome. And women have 2 X chromosomes where men only have 1. Therefore, if a woman inherits a defective color vision gene or is missing a color vision gene, she can rely upon the set that's on the other X chromosome to give her normal color vision.
Often, color blindness is little more than an inconvenience. But there are jobs in which accurate color perception is critical. For example, in flying commercial aircraft. Why is that, Elizabeth?
Well, it's very important that they be able to distinguish landing lights.
Oh, yes, I guess so. So how does it work? How can you test it?
Elizabeth Armitage at Air Canada's medical clinic in Toronto.
And there are 8 numbers there, and alphabetically, I'll call them out to you. A.
12.
B.
Is 5.
C.
26.
D.
Blah, 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 blah.
Exactly.
So.
Well, your color's perfect, David.
Great. So I can fly a plane.
Well, it takes more than color per...
How does it work?
Okay. These are red and green deficiency. A normal person would read this as 8 and 6. But with a red-green deficiency, they read it as a 3 and a 5.
I see.
Okay, this is the same thing, a red-green deficiency. Normal people see it as 5 and 3, but with deficiency, it's seen as a 2 and a 5. But that's basically what you were looking at in the machine here.
Of course, seeing is also a subjective process, so even people who are colorblind are often unaware of it until it's brought to their attention.
When I was 4 years old, I got dressed and came downstairs, and my mom said that my color combination of clothes didn't match at all or didn't go together very well. And so we kind of knew that I didn't see colors the same way that most people do.
Most of us have colors we like and others we hate, but how profoundly do they affect us? Alexander Schaus of the American Institute for Biosocial Research.
People have had a lot of theories about whether red excites or orange does this or yellow does that, and the really exciting part of the last 20 years has been that researchers have finally received funding to find out really what colors do to us physiologically that's consistent.
A carefully set up and documented investigation into some of the effects of color included Norwood School near Edmonton. The current principal is David Hitchcock.
Our school was selected 10 years ago to take part in an experiment undertaken by Alberta Education in color and light in school. We have full spectrum lighting in the school, and the rooms of the school are painted in 2 different colors.
This is where we made our chart.
Under the direction of Professor Harry Wohlfarth, the classroom walls which the children saw were painted a stimulating shade of yellow, while the wall and desks that the teachers faced were a calming blue.
Some of the studies, such as Professor Wohlfarth at the University of Alberta, where he has actually hooked people up to electrodes and watched using computer-assisted EEG technology to look at what does the brain do and which regions of the brain respond to different colors.
As a control, 3 other schools were made over with different combinations of colors and light. Professor Wohlfarth.
We took eye tests, blood pressure measurements of all the teachers, principals, and 10 students per class, per school, twice a month. Norwood School, color and light, had pretty well in general the best results.
I was skeptical at first. I didn't think that colors could make a difference in how you felt. But I admit that I did notice that the blue, after I'd been in the school for a while, did make me feel calmer.
I particularly gravitate to the blue colors as opposed to the yellow colors, but I know that others find that the invigorating colors are more to their liking. And we find this also for the children.
At Norwood, color was used to produce a general sense of well-being and increased energy. But colors can be targeted to more specific goals.
How colors can be used very effectively from a beneficial standpoint occurred in London, England, when the government there was very, very concerned with the number of suicides occurring off the Blackfriar Bridge, which was painted all black. And we had recommended a color called Ertel blue. And in fact, the London Council did authorize that the bridge be repainted. And since then, the suicide rate has been literally the lowest of all the bridges. Color is not going to be used in some insidious fashion to control people. We have a long way to go in really understanding which colors do what. And this is just the beginning of a new frontier of our understanding of a basically new technology that's available to us in this century.
However, the use of color for healing is well established. This premature baby, wearing goggles to protect his eyes, has jaundice, which will be treated with ultraviolet light. Dr. Jonathan Hellman.
The jaundice is due to the presence in the blood and in the tissues of a yellow pigment called bilirubin, which is due to breakdown of red blood cells. And for that, he's receiving light therapy or phototherapy from this unit above the incubator. The light gets through the skin, penetrates the skin, and is absorbed by the bilirubin molecule. And it enables the baby to partially bypass the normal process for getting rid of this bilirubin pigment. It was noticed probably more than 30 years ago that the babies closest to the windows seemed to have lower levels of jaundice. And it was recognized that something in the light was affecting that level.
Indiscriminate exposure to the sun's ultraviolet rays is a hazard everyone should be aware of by now, though not all of us are. The risk of causing cancers over time is especially significant for youngsters. Dermatologist Dr. Cheryl Rosen sees another side to ultraviolet light.
In spite of the fact that we know that ultraviolet radiation is harmful to the skin, damages DNA, can cause mutations in the skin, can produce skin cancer of various types, we know that paradoxically it's very beneficial in treating certain skin diseases. We see a lot of people who have fairly extensive psoriasis that can be quite itchy and thus interfere with their life. We can deal with this in a variety of methods, but one of the ways to treat this is with ultraviolet B radiation on a daily basis, starting at a very low dose and gradually increasing to higher amounts of ultraviolet B radiation.
Many years ago, people started doing some research on looking at certain colors to reduce pain, to try to reduce the requirements for analgesics, painkillers. And the color that has rather consistently been shown in hospital studies and clinical trials to reduce the need for pain medication have been certain shades of blue. This is another example of a new frontier in the area of how colors can be used from a healing standpoint.
But how far does color therapy go? Renee Brody belongs to the International Association of Color Therapists.
The whole idea of color, then, is to help people towards self-healing through the knowledge of color. And if you know about color, you can help yourself.
I would think there would be areas, hospitals, maybe prisons, where the role of color might be quite demonstrable.
They're beginning to do that now, David. Bubblegum pink, for instance, has been used in institutions. Prisoners who are very violent, and they put them in the bubblegum pink room, and they calm down. There are other ways to calm yourself. You can go out in the garden or something like that and breathe in the colors there. And there's the blue sky, this great expanse, and people can walk to work looking at the blue, which is peace. Give them peace before they get to work.
When we come back, Masters of Disguise.
Looking for a great holiday value? Call Thomas Cook Travel right now and save up to $500 on a Carnival cruise to the tropics. Almost everything is included. 7 sunny days at sea, exotic ports.
The Mendi of New Guinea traditionally painted themselves for ceremonies and war. Their natural colors were made mostly from vegetables and minerals. Minerals were also the source of pigments used for the famous Lascaux cave paintings. As time went by, other natural sources of color were discovered. Tom Eisner.
Then came the first animal dyes, which included purple, which they obtained from snails in the Mediterranean. 12,000 snails to get 1 gram of dye. The Emperor Purple, this is what Caesar said, only my mantle and the stripes and the generals in that color. That's how precious that was. And they fished these snails almost to extinction.
What exactly are we looking for, Tom?
Well, what we're looking for is prickly pears with a type of insect on it. In fact, there's some, watch the spines.
Oh, yes.
This is a cochineal insect.
But I mean, the white isn't the bugs.
The white is a cover. It's under this white stuff. And as you can see, I can pluck that away.
Right.
And it turns out the wax is carried by these silken threads, which, as you can see, are very distensible. But under this white mass is this little purple blob.
Now that is small.
That is small, and that is red.
Right, right.
And that's the purpose of the whole thing. It's a red dye, which in history was incredibly valuable. The Spaniards, when they opened up their colonies, used this as one of their major exports. In importance, it was second only to gold and silver. I happen to have a jar with a commercial product right on me. This is a jar of cochineal. And what I have here, have some.
So each one of those is one insect.
And with just a couple of these, I could stain your whole shirt in its present color. It's amazing. In fact, I'll show you the
It
dye.
doesn't look like much like that.
Not much like that, but I'll tell you what we'll do. We're going to dissolve a couple of these in water. Stir things up a little bit. And you're going to see cochineal red in the making.
That's a beautiful red.
Cochineal is still used on a small scale as a specialty dye. Marilyn Leonard.
We're stirring the dye pot with the yarn in it. You need at least half an hour to an hour of simmering, depending on the color you want it to reach. If you don't cook it long enough, about 15 minutes, then when you go to rinse it, all the color will rinse out. Then once we finish simmering it for the hour, we'll take it and we'll rinse it in clear water 2 to 3 times, squeeze out the moisture without wringing, and hang it up to dry.
Natural dyes had no real competition till well into the 19th century when aniline dyes, derived from coal, were first produced. It was claimed these new synthetic colors were more consistent and resisted fading.
The difference between the aniline dyes and natural dyes is in the quality of the color. The natural dyes will be much softer, and they also fade and grow and become more beautiful as in old rugs. They're always harmonious and beautiful.
Cochineal is an exception among natural dyes. It's remarkably stable.
Some of the old fibers that were stained by the Incas still retained the brilliant red that they had at that time. And cochineal was so valued because of its stability, resistant to bleaching in sun, resistant to bleaching as a consequence of washing. So it has these very, very special characteristics.
You know, it's not just a matter of taking some berries and squashing them and then putting clothes in them and dyeing them. I mean, a lot of these require a very complicated series of steps. How did people find them out?
There's so much that they learned by trial and error. I would like to believe that the years that we often waste in school, they used to their own gain by exploring and inventing. They're the most imaginative years, the most creative years of a person. And if we look into what the knowledge is that was already in our ancestors, we might perhaps have much more respect for them.
Might be a little humbling.
Much more.
In color theory, there are 3 primary colors, which cannot be made from other colors, but which combined in pairs produce secondary colors. Colors opposite one another are called complementary. For the artist, color theories are meant as an aid, not a straitjacket. When it comes to putting paint on canvas, anything that works goes. Mindy Campaneschi.
The beginning is the most difficult part. So I like to be the most free possible at that moment with the color. I just spill it or I just paint it on in completely unknown ways. In this case, I specifically wanted to use the primaries because I know that when I start to combine them together, when I start to move them into each other, they'll produce some wonderful effects. And color effects are what, of course, gives pleasure in the painting. Color has a transformative quality, which is something that makes it very magical and makes the painter live in an almost a sort of a mystical and magical kind of realm. It's not just those wavelengths. It affects you. For instance, I start to work with a certain purple and suddenly I'm tasting blueberries.
The painting process itself is subjective, the artist feeling her way into what she wants to express. A few weeks later, she can be more objective.
It's a very good example of what you can do with color and how color interacts. These wings of the angel are in warm colors, cool colors. It creates an ambiguity for me, as if they could almost be flapping. Then, well, the more reddish part of this orange-red starts to play with these little bits of green in here. I find my eye jumping back and forth. So it gives motion to the painting. Color is extremely exciting. It's exciting visually, and it's stimulating mentally. And of course, that's the mystery of color, because really, how does that work? Why is it that some particular color has that effect to excite your brain, to excite your whole body?
For those involved in any kind of color reproduction, the key word, always, is accuracy. Como in northern Italy has a long tradition of silk printing and is renowned for the ability of its craftspeople to exactly reproduce the subtlest details of an original design, like those of New York fabric designer Audrey Buckner. In creating these designs, she not only expresses her personal taste, but has to anticipate what her customers are likely to be looking for. And this involves a shrewd understanding of the way in which different people perceive color.
Which is the really crucial part of my work, because the design is one thing, and that takes a lot of work and preciseness, but the color really determines how people receive it. When I'm doing my colorations, I try to do that at the same time every day, because the light affects the color. Color affects our moods, and it's a very personal kind of thing. Red may be your favorite color for reasons you may not be able to explain, and it may be a color that I don't like. Color has a special vocabulary. It says something about you. It speaks, and in our clothing, that's reflected.
Even in our species, the choice of what we wear depends on more than mere decoration or just keeping warm. We communicate all kinds of things about ourselves through the clothes we wear. That we're wealthy, that we're rebels, that we're down-to-earth folks who don't care at all about fashions. But whatever the message, the intent is to reveal to our peers something about the kind of person we are or would like to be. And with luck, to attract like-minded companions. In the animal kingdom, color is also used to communicate.
But much more than with us, color and patterns are used for concealment. Patterning, like the giraffes, tends to break up shapes. It makes animals harder to see. When it comes to concealment, however, the unquestioned master is the chameleon. Gary Ferguson of Texas Christian University.
Chameleons are really masters of color change among reptiles and probably among most vertebrates. And they change colors for several reasons. They change their color often subtly to match their background. But the dramatic color changes due to display communicative information to social partners. They are almost completely visual in their communicative strategies.
Cuttlefish could be called the chameleons of the sea. They're members of the cephalopod family, which includes octopus and squid. Marine biologist Roger Hanlon has studied them extensively.
There are two unique and really exciting features about color and pattern change in cephalopods, and that is the speed and the diversity that they can show towards a predator, towards another squid or octopus or whatever the case may be. And the speed comes from direct neural control from the brain straight into the skin. It's not a slow hormonal change like chameleons and other animal groups. It's direct nervous input that can implement a change in color or pattern within a fraction of a second. It's really extraordinary. And the second thing related to that is the diversity that each individual animal can show. One squid can show 30, 35 different patterns in the skin, each one perhaps with a different color or brightness. So if a predator comes, they can show something very specific to that predator. They'll turn on some false eye spots on the back of the body. And these false eye spots are larger and darker than the real eyes. Sort of a boo, stay away from me, I'm bigger than you think I am.
Cuttlefish also employ an amazing banding or cloud effect, which makes it difficult for predators to determine which direction they're traveling in. And they can perfectly mimic the colors of the ocean floor.
The interesting thing is that all the evidence we have shows that they are not capable of color vision. And we can't explain this very well. If they can't really tell the exact color on the bottom, how do they match it so beautifully?
Another of nature's great mimics, one who demonstrates his gift on canvas and paper. Artist and author of the Field Guides, Roger Torrey Peterson.
There's an extraordinary interaction between light and color. I find that I work best in the morning here with a fairly sunny day. I can be quite accurate and I see color more perceptively.
Working on his guides and magnificent bird portraits has given Peterson a unique understanding of color in nature.
When you look at the whole spectrum of color in birds, it is complicated because some birds are alike. The males and females are alike. You can't really tell a male blue jay from a female, except possibly from their actions. And there are many birds of that sort. And then those birds that are where the male is bright and the female is dull, you can see why a female might be dull because they are vulnerable when they're nesting. And then birds that match the landscape, of course, ones that are camouflaged. There's many of those. The thing about studying nature or painting, you never get to the end of it. Color is important, very important, because I know I depend on it. I see it, I revel in it, I love it. Color and light, those are the two things. They're life itself.
David Suzuki will be right back with a look at our next show, Herschel, an island of flowers in a sea of ice.
Hey, Remington, shave this.
If you can grow it, we can shave it. Remington introduces the triple foil. The only shaver with 3 narrow microscreens to cross-cut each whisker 3 times. For hard-to-shave places on hard-to-shave faces. No one else has anything like the Remington triple foil.
If you can grow it, we can shave it.
There is a company that believes this may actually be man's best friend, after all. And while it's not surprising that this same company created the modern crash test dummy, it is somewhat more remarkable that shortly thereafter, they shared it with all their competitors. Then again, when it comes to safety, they've shared numerous patents over the years, so everyone can ride a little safer. The company is General Motors.
Monica Domofsky loved her clone until she called for service and got excuses. She switched to IBM Value Point with lifetime support. Her old clone, it serves whiskers just fine now.
Think deeper. Think further. Think better. ThinkPad.
There's a perfect wine for almost every occasion. This afternoon, Robert is chilling a fine bottle of Chardonnay from the vineyards of Ernest and Giulio Gallo, two men who've spent over half a century perfecting their art. What could be more perfect? Well, almost perfect. The Chardonnay of Ernest and Giulio Gallo.
I'll be home for Christmas.
When we think of a jolly old guy in a red coat, we think of Henry.
Merry Christmas. Got all kinds of terrific gifts.
He's got all kinds of friendly advice.
Don't forget our great prices.
For the handyman, choose the Delta 8 1/4-inch compound miter saw, only $179.97.
Looking good, Santa. So where are all your gifts?
I've got some friends in the biz.
I'll be home for Christmas. Home of the handyman.
If you want to know the quality of the carpet, look at the pile. I've investigated all of the piles at Palazzi Carpet and Tile, and it's deep, rich Canadian quality at deep down American prices. The great pricing continues on marble and granite, custom cut and polished, right here at Palazzi. Unbelievable quality at competitive prices. Either side of the border.
Week, a visit to far-off places, to Ghana in Africa, to witness a grassroots